Okay, so welcome back to Unit 3, Circular Motion and Gravitation. The next section in this notes packet is going to focus on the fundamental forces. So this is going to be a quick little thing just to kind of talk about what these forces are. We've been talking about all these forces, but ultimately what happens in the end, in nature, right, there's going to be basic forces, and we call them the fundamental forces. Okay, they are the lowest, right, force that we can that we focus on. And in fact, what happens is all the other forces can be explained using these four forces, okay? And so if a force is what is called non-fundamental, okay, that's what we say, is that it's if it's not one of these, we consider it to be non-fundamental, but we can take those non-fundamental forces and explain them using fundamental forces. So for example, friction, right? Friction is a non-fundamental force, okay? It's not going to be in this chart, okay? However, if you remember from the equation, friction is mu Fn, but the majority of the time Fn was mg. This is weight. Well, remember, what is weight? It's the gravitational pull, right? Which leads me right into what is the first fundamental force? Gravity. Right? So you can see I took a non-fundamental force, right? NFF, non-fundamental force, and I explained it using a fundamental force. Okay? So the way that this chart is set up is you got the force, you have the relative strength. So how do they compare? Okay, the range over which they act, and just a little brief description, okay, as to where they come from, all right, or cause. So gravity has a relative strength of 10 to the negative, it looks like 47th. I can't read my own handwriting. Okay, I may need to go back and change that number here in a little bit. It has an infinite range, which means it can act for a distance of infinity between objects, which means if you think about it, you go to the outer reaches of the universe, there's still a gravitational pull between the Earth and that object way out there, okay? Now, what happens? So it affects all objects that have mass and energy. Okay, and then the cause is up for debate, right? This is one of the big big things of like what really causes causes gravity. They're calling it the graviton. Okay, and so what happens is if you go and research the gravity blip, the gravity blip is a sound bite that they propose is what the gravity wave is. Okay, and for the most part, we know what causes the other three fundamental forces. Gravity is still the unknown. Okay, and I know my eye here almost looks like a J. Okay, but if you go search gravity blip, you'll actually hear a sound file of the proposed gravity wave. All right, so the next fundamental force is what we call the weak nuclear force. And you'll see the reason why I'm going to organize these the way they are here in a second. I'll explain. Okay, it acts, it has a relative strength of 10 to the negative 6. Okay, it acts on a range of 10 to the negative 18, which is about the size of a proton. And because what happens is this is the force that holds a proton together. Okay, and it governs decay. All right, so it governs some of those radioactive decays that we see, alpha, beta, gamma, and more specifically, beta plus and beta minus. If you're really interested in those topics, those are nuclear physics topics, and it's interesting how the plus and minus work in this scenario. Okay, the next force, or the next fundamental force, is the electromagnetic force. It has a relative strength of 1/137. It also, like gravity, has an infinite range. Okay, and this force affects charged particles. Okay, so electrons, protons, right, particles that have charge to it, and it's actually created, or it's caused by a photon. Photon is just a massless packet of energy that moves at high rates of speed, near the speed of light. Light is actually a photon. Okay, the next, or the last fundamental force is the strong nuclear force. It has a relative strength of 1, and it acts on a range of 10 to the negative 15th, which is actually the size of a nucleus, or roughly the size of a nucleus. And this is the force that does hold the nucleus together. Okay, so when when scientists and physicists do nuclear fission, they're working against this force to break that apart, and that's where all the energy comes from. Okay, so just a quick little recap. In fact, the way this works is that gravity is the weakest, and strong nuclear force is the strongest. Okay, and then you got weak and electromagnetic force, and you can tell that. That's why I put this column in here talking about the relative strength. Okay, a way to think about it is you can break gravity very easily by simply jumping. Well, you have to use particles traveling at high rates of speed to break apart the nucleus of an atom, right? So that's how you have to think about the way that those forces act. Okay. Next, we're going to continue to talk about this gravitational force. We're going to put it into, we've already have an equation for it, but now we're going to introduce it in another equation.